Hello students, today we are going to perform the synthesis of 2,4,5-triphenylimidazole.
Students, let us see the requirement for our today's practical, that is synthesis of 2,4,5-triphenylimidazole. The requirements are as apparatus required are round bottom flask, beaker, conical flask, measuring cylinder, funnel, glass rod. And chemicals required are benzene, ammonium acetate, benzaldehyde, glacial acetic acid. Let us see the reaction involved in this synthesis. Benzene, when reacted with the benzaldehyde in presence of ammonia, the heating of this mixture is carried out near about at 100 degrees Celsius. Reflux is carried out for 5 to 24 hours. Then 2,4,5-triphenylimidazole synthesis takes place. Let us see the principle involved in this synthesis. The debut Rad-Cis-V imidazole synthesis is an organic reaction which is used for the synthesis of an imidazole derivatives from a dicarbonyl, an aldehyde and the ammonia. So, the dicarbonyl component is commonly glyoxal but can also include the various 1,2-diketones and the ketoaldehydes. This method is used commercially to produce several imidazoles. The process is an example of multi-component reaction. Let us see the mechanism involved in this synthesis. The mechanism involved basically two important steps. In the first step, one diketone molecule, you can see over here, that react with the ammonia to form a diimine, and there is the water molecule removal takes place. In the second step, this diimine condenses with the aldehyde molecule to form substituted imidazole derivative. Students, let us see the practical procedure for our today's practical. In round bottom flask, you have to place a benzene, benzaldehyde, glacial acetic acid and ammonium acetate 1 gram. You have to reflux this mixture for 3 hours. After refluxing, allow this mixture to stand for a room temperature to attain the room temperature. After the cooling of the reaction mixture at a room temperature, add 150 ml of water and then precipitate out instead of precipitate, you have to filter out the sample or the synthesized compound. Then filtered is neutralized with the ammonium hydroxide, and that ammonium after neutralization of ammonium hydroxide, that mixture will give you a pasty mass, and that pasty mass you have to filter, and that after drying it will be your final product. Then report the yield of the product. So students, let us see the actual synthesis of our today's practical.
Students, let us start the synthesis of 2,4,5-triphenylimidazole. Before starting actual synthesis, let us see the requirement for our today's practical. For this practical, we will require some chemicals and glasswares. In chemicals, we will require glacial acetic acid, ammonium acetate, benzaldehyde, benzene. Okay, along with these chemicals, we will require some glasswares, pipette, beakers, funnel, glass rod, spatula, tripod stand, porcelain piece. Then we will require the condenser assembly. Okay, in this we will require this condenser, this round bottom flask, then water bath, wire gauze, tripod stand and the inlet and outlet tubing. So student, you have to remember, this is your inlet, okay, and this is outlet tubing. Student, let us start the actual procedure of our synthesis. For this we have to take 1 gram of benzene. Now I am transferring the benzene into the round bottom flask. This 1 gram of benzene. Okay. Then we have to transfer the 1 gram of ammonium acetate. Okay, I have already weighed the quantity of ammonium acetate also. So I am transferring the 1 gram of ammonium acetate. After this, we have to take 2 ml of benzaldehyde solution. With the help of pipette, I am transferring the benzaldehyde to the round bottom flask. Okay. This is only 1 ml. I am transferring more 1 ml. So here I have transferred the 2 ml of benzaldehyde solution to the round bottom flask. Now we have to transfer again 2 ml of glacial acetic acid solution. Again with the help of pipette I am transferring this. Okay. After complete addition of benzaldehyde, acetic acid, benzene and ammonium acetate into the round bottom flask, I am adding a porcelain piece into the reaction mixture to avoid the bumping of the solution. Now we will join this RBF to the condenser. So this RBF is fitted to the condenser. Okay, make sure that connections are proper. Okay. Now we have to start the heating. Now I am starting the inlet connection. Water inlet is started. You can observe the water level is increases into the condenser. Okay. You have to maintain the flow of water into the condenser. Now our complete assembly is ready. We have started the synthesis. Now we have to wait for next 3 hours. Up to the 3 hours you have to heat the reaction mixture. Students, you can observe the change in the color of the solution. Okay, it is going to be a yellow color. Okay, we have completed near about our half an hour of the synthesis. Students, now you can observe after the completion of 1 hour, the reaction mixture is completely converted into a near about orange color. Okay, you can observe. So students, we have completed our 3-hour sitting. Now I am turning off the burner. Now we will remove our reaction mixture from the condenser. Okay. Wait for some time. Let it be cool. Now I am stopping the water inlet. Okay. Allow this reaction mixture to stand at a room temperature for near about 5 minutes. So students, we have wait for the 5 to 10 minutes. Now we have to transfer this content into the beaker. Okay. You can observe still it is very hot. Okay. Now we have to transfer near about 150 ml water into this content. First of all, I am transferring this water into flask, so the content of the flask will be completely removed. Okay. Now we have to add near about 150 ml of water. So student, we have got this our final solution. Now we have to neutralize this solution with the ammonium hydroxide. Okay. So we are going to add ammonium hydroxide. Okay. At the same time, we have to continuously stir the reaction mixture. You can observe in the beaker, product is precipitating out. Students, now we will continue with the filtration. Okay. Students, now we continue our filtration with the washing with water. Okay, I am giving the washing with water. So unreacted benzaldehyde, benzyl, acetic acid will be removed from the final product. Student, this is our crude product. Now we will proceed for the further drying in hot air oven. Now we will proceed for the further drying in the hot air oven. We have to wait for near about 10 to 15 minutes for drying of our product. So students, you can observe this as our final product of 2,4,5 triphenylimidazole.
Students, let us see the calculation involved in the synthesis of 2,4,5-triphenylimidazole. So 210.23 gram of benzene is equivalent to 296.4 gram of 2,4,5-triphenylimidazole. As we have taken the 1 gram of benzene as a starting material, which is equivalent to the x gram of 2,4,5-triphenylimidazole, and this x is nothing but our theoretical yield. To calculate this quantity or value of x, we have to do the cross multiplication, that is 1 into 296.4 divided by 210.23. So x will be 1.40 gram. Now we will calculate the percentage yield. The formula to calculate the percentage yield is practical yield upon theoretical yield into 100. So just put up the value for practical yield and the theoretical yield. As we have got 1.2 gram as in practical yield and 1.40 gram of theoretical yield. So by solving this, we will get our percentage yield as 85.57%. Next part is uses of these 2,4,5-triphenylimidazole derivatives. These derivatives having variety of uses, or you can say this molecule 2,4,5-triphenylimidazole is basic molecule present in variety of medicinal agents like antifungal, antibacterial, anti-inflammatory agents, analgesic agent, antitubercular, antidepressant, anti-cancer and antiviral agents. So these 2,4,5-triphenylimidazole derivatives having this much activity like antifungal, antibacterial, anti-inflammatory, analgesic, anti-TB, antidepressant, anti-cancer and antiviral activity. Let us see the properties of 2,4,5-triphenylimidazole. The molecular formula for this compound is C21H16N2. Molecular weight for 2,4,5-triphenylimidazole is 296.4. The synonym for the compound is 2,4,5-triphenylimidazole, 2,4,5-triphenyl 1H imidazole. The melting point for this compound is 274 to 278 degree Celsius. These compounds appears as a off-white powder and soluble in methanol and insoluble in water. So students, now we can conclude the result for our today's practical as the percentage yield of 2,4,5-triphenylimidazole was found 85.57%. Let us discuss the question bank. So our first question is, give the reaction involved in the synthesis of 2,4,5-triphenylimidazole. So when benzene in presence of ammonia and benzaldehyde allow to reflux for 5 to 24 hours, the rearrangement type of reaction takes place to form 2,4,5-triphenylimidazole. Our second question is, explain the principle involved in synthesis of 2,4,5-triphenylimidazole. The Debus-Radzivsky imidazole synthesis is an organic reaction which is used for the synthesis of imidazole from a dicarbonyl, an aldehyde and ammonia. The dicarbonyl compound is commonly glyoxal but can also include various 1,2-diketones and the ketonaldehydes. The method is used commercially to produce several imidazole. The process is an example of multi-component reaction. Next question, Give the mechanism involved in the synthesis of 2,4,5-triphenylimidazole. The two steps involved in this mechanism. The first step is the diketone and the ammonia form an diimine. You can see in reaction this diketone and the ammonia react with the removal of water and that will form the diimine. And in second step this diimine condense with the aldehyde to form our imidazole derivatives. Next question. Explain the procedure for synthesis of 2,4,5-triphenylimidazole. So procedure for this practical synthesis is in round bottom flask place of benzene, benzaldehyde, glacial acetic acid and the ammonium acetate. Reflux this mixture for near about 3 hours. After the reflux, allow this reaction mixture to stand for the room temperature. Then add this mixture to the 150 ml of water. Then filter. Then that filtrate is neutralized with the ammonium hydroxide solution to give a pasty mass and then filter off the product, dry it and report yield. Next question. Give the uses for the 2,4,5-triphenylimidazole derivatives. These 2,4,5-triphenylimidazole derivatives having antifungal, antibacterial, anti-inflammatory, analgesic, antitubercular, antidepressant, anti-cancer and the antiviral activity. Next question. Draw the structure for benzyl, benzaldehyde and 2,4,5-triphenylimidazole. So this is the structure for benzyl. Next is benzaldehyde and last for 2,4,5-triphenylimidazole. Students, I hope you have understood our today's practical, that is synthesis of 2,4,5-triphenylimidazole. Thank you.